Okay, welcome back. We're going to go over Chapter 2, which is Basic Elements of Java. And I am going to record several videos, not sure how many for Chapter 2, but we're going to stop where we start talking about the class strings. So that will be on a separate video. Okay, so let me share my screen. I'm going to be using the PowerPoint slides that I included under assignment 0 online Java compiler that I posted a message about. So I do have Eclipse installed on my machine, which I've always used, but I wanted to use the online Java compiler because I feel like a lot of students have difficulty installing the compiler, and that's not the main point. The main point is just programming, learning the language. So this is the online Java compiler. There are other ones that you can try out and see what you think. For now, I'll just minimize that. Okay, so looking at Chapter 2, we are going to really look at just how to write a very basic program and what everything means that we're typing. If this is the first time that you've taken a programming class, then this will be very valuable. If you've taken a programming class before, like C++ or some other language, then some of this will look familiar, and they'll, you'll kind of remember it from other programming languages that you've taken. So I'm going to start with what is a computer program versus programming. So an actual program contains let's see if I can figure out where to put this little picture so it's out of our way, a sequence of statements. And our whole purpose is just to accomplish a task, okay? So we're writing programs to make people's life easier in some way or another. And the act of actually programming, so this is a verb, it's just where we actually write our programs, we plan and create the actual code. So this is an example of a Java program. I cannot figure out where to put this thing. Okay. And starting from the very top, we have comments here. If you've taken a C++ class, you've seen these type of comments, because that's, Java came after C and C++. So C++ came from C, and then Java came, and it has a lot of the features of C and C++. So you'll notice that it looks a lot like C++, and that's why we have it as typically it's a precursor to this class. So whenever you have 2 forward slashes, it comments the whole entire line. So 2 forward slashes comments the whole entire line, which means that when this program is ran, the compiler doesn't even look at it. It just skips those lines. And then we have public class. So the name of this program or class is a simple Java program. In Java, every program has to have a class, and inside the class, if you're writing an application, which is what we're writing applications. We're not writing like web. We're not writing web apps. We're writing applications that run outside outside the web. And so because it's an application that can just run on, let's say from your desktop, then we have to have a function called main. If we don't have, or a method. So in Java, they're called methods. And I'm sorry, sometimes I'll go back between functions and methods because I teach C++ also. and the terminology is different. So this is a method, and in a class, you have at least one method. If you're writing applications and your method is main, we will write other methods later on. And so these words here that you see in blue, and they're going to be in light blue in your book, are reserved words. So, which means that they have a specific task. Somebody has actually programmed these words to do something, and we can't change that. We can't use these words as variables or anything. They have to be spelled just like this. They have to be lowercase, and they have one specific task. And then, so we have public class, a simple Java program. So this is the name of our program. We have main. We'll talk about the method arguments, the things that go in parentheses later on when we get into methods. So for right now, you're just going to put this in there and don't worry about why. Notice you have this open curly brace, this closed curly brace, this one and this one are for the class. This one, oops, go back. This one and this one are for the main method. So this is what we call the body of the method right here. It's the things between the open and curly brace. It's also called a code block. So this is the code block right here. Inside this code block, we have 3 output statements. So print line, it's going to output to our desktop or wherever you're running this. So it displays on the console. That's what I'm trying to say. So we can also print to a text file or to something else, but this is actually printing to the console. And whatever's in quotes, it's what's going to get printed. So we have an open parentheses, open quote, some characters, close quote, close parentheses, semicolon. Each statement has to end in a semicolon. Everything that it's in quotes means that it's going to print exactly what you put in quotes. They're just characters. Even this 2 and this 3, they're not numbers. They're considered characters because they're in quotes. So this is called a string, everything inside the quotes. Now, here you have a plus sign. What the plus sign does is it concatenates, or it adds to the string. And here we're just adding a 5 to the string. You could have just put that 5 inside the double quotes and not have to do this. But here's just showing you other things that you can do in your print line statement. Here, it's also the plus sign means take the 7, add it to the 8, which we get 15. And then after you add that 15, go ahead and print it next to 7 plus 8 equals. So this one outputs 7 plus 8 equals, here's the equal sign. And then there's a space right there. And then this 15 comes from this addition right there when we add. So when you're output into the screen, if you want spaces, those spaces have to be in the double quotes. So a Java program is a collection of classes. Here we have one class, but we have one class that we created. It's called a simple Java program, but there's also classes that we use that are included as part of a library that and one of those is called a string class, which will be, I said earlier, a different video. And so we can have one or multiple classes that we create, and we can have classes that we have already created by somebody else that we get to use. There's a main method, like I said, in every Java application program, not if we're creating an applet, which runs on the web browser. And then a token is just the word that we use for the smallest individual unit of a program. And the smallest individual unit of a program, it's going to be the Java class. These are some special symbols that we use in Java, and they look a lot like it's up here. They look a lot like C++. But I did want to show you one thing. I want to go back. If you have taken C before, this print line statement actually came from C programming, and then C++ doesn't use it. You can use it in your C++ programs, but it comes from C. So it's just interesting. And, you know, semicolon also in main, all that came from C. So here we have addition. Here we could add, or we could, if you have this in front of a number like +5, it just means that 5 is a positive number. You can use this to subtract two numbers like 8 minus 3, or you can use it in front of a number like -8. It just means that 8 is a negative number. We have multiplication. This is / is division. Then we have some punctuation marks. These are that we use for different reasons in Java. So the one that you've seen so far is the semicolon, and the semicolon is used to end each statement. So at the end of each statement, you have a semicolon. But notice that you don't have it at the end of here. You don't have a semicolon there. The end of this is the header of your method. There's not one at the header of the method. There's not one at the end of the name of the class. So right now they're just the statements. These print line and some other statements we'll look at later on. So something to note, because you'll get errors if you put semicolons in the wrong place. And then we'll talk about the question mark later. We'll talk about the comma and the period we'll use later. But they're special symbols, which means that we're not going to use them when we create variable names. And if you've taken a programming class before, you know what, there's all kinds of syntax rules for variables. If you take algebra, some kind of math class of variables like the letter X or the letter Y. So we can't have these special symbols in our variable names. These here are comparison operators. So this checks to see if whatever's on the left side is less than or equal to whatever's on the right. This means not equal to. This means equal to. And the reason that it's two equal signs, really important. One equal signs means to assign. One equal signs means like X equals 5, and X now is at 5. Two equal signs, if you say, is X equal to 5, you got to have two equal signs. So make sure you use two of them if you're trying to compare two things at each end. And then we have greater than or equal to comparison. These are some reserved words, also called keywords. Same thing, a keyword or reserved word is a word that, like we said earlier, it's been defined to do something specific, and we cannot redefine it. We cannot say, oh, I want return to mean something different. And so they're always going to be, in your book, they're going to be light blue. But in your compiler, you can set it to whatever color you want. And the compiler that we're using, so public and class, they're purple, they're orange, and somewhere in here you could probably edit the colors. I have not played with this compiler at all, but we can change the colors. So right now, anything that is a keyword or reserved is orange. And then here, this string here, which we'll talk about later. This is the class, and then system is also a class. These are methods. Print line. Main is a method that we're creating. So let's go back over here. Okay, so these are our reserve words or our keywords. And there's actually in your appendix, I think it's Appendix A, there's a huge list of all of the reserved words. Look right now. Various appendix. Yeah. So I'm just going to show you real quick. This is Appendix A, and it has a list of all the reserved words. So when we're creating variables, we just want to make sure we don't use those as variables, but it's okay. You don't have to remember them. You don't have to know what they are, because if you try to use one of them, it will let you know the compiler will give you an error. It's going to turn it orange or whatever color, and you'll know anyway. Okay, so there's that. Java identifiers, these are, I've been talking about variables. So when you're creating a variable, they're or an identifier identifies a variable, an identifier for a variable, or identifier for constant, or an identifier for a method. So basically it identifies something. It has to have some rules that you have to follow, which is the syntax. And so it can have letters, it can have digits, it can have underscores and dollar signs. The identifier has to start with a letter, or it must begin with a letter, an underscore, or the dollar sign. So those are the only things it can start with. It cannot start with a number, because whenever the compiler sees a number, it thinks that you're about to do some kind of calculation. So if you call the variable 2x, it thinks you want to then multiply or do something with 2 and x, like multiply it or add it together or something. And it's going to look for something to go in the middle. So it's going to give you an error because you've forgotten something. So you got to start with a letter, an underscore, or the dollar sign. You'll see that you'll see that all variables that are created follow just this is not a rule, but mostly it's trying to think of a specific word, but it's just how we identify variables and constants, is that we start them with letters. It's just what we do. And we pick names that make sense. We don't make weird things. We don't call just a variable, you know, an X, unless it's going to be a counter, something really simple. But if your variables to find the sum of something, then just call it sum. If the variable is going to hold a last name, then just call it last name. We don't make up weird variables. We have simple names that tell us what that data is going to hold. Okay, so those are identifiers. So let's take a look at some examples. This here is employee salary. It's an illegal identifier because it has a space. This would be a beautiful identifier if we put it together, if we move the S over, or if we put an underscore in between. That would be a really nice identifier, the employee salary. Hello exclamation point, it's invalid because it has the exclamation point. We can only have letters, numbers, underscores, and the dollar signs. These are the only things that we can have. This one is illegal identifier because it has the plus sign. So here, actually, what the compiler thinks is happening here would be that the compiler would think that 1 is a variable and 2 is a variable, and you're going to add these two variables together. Maybe they're integers, like a hold of 5 and a 6 or something. And then this is invalid because it starts with a number. It cannot start with the number. So start with a letter, underscore, or $sign. So when we have variables or constants, we have to decide what data type is this variable going to be defined as. So that's going to depend on what the variable is going to hold. So data type is a set of values together with a set of operations. Let's take a look at the different types of data types. So our different types of data types are integral data types, which are data types that do not have decimals. They only have, it's just a whole number, like 100, 1,000. Floating point contains decimals. Boolean is just true or false. We do a lot of true and false in programming. When we have conditions, we have to check, like, did he press enter, or is the password valid, yay or nay? So lots of checking, true, false, lots of things to help us with loops and conditions. And so these are the primitive data types. Meaning, like, so these are included with the compiler. It's not a class that's created, it's just a primitive data type. So the integral data types, you have, again, these hold just whole numbers, no decimals. We have the char data type, byte, short, int, long. So I'm going to start here with these three: short, int, and long. So each one of these, I don't know if I have, yeah, here they are. Okay. So each one of these is a different size. So looking at short, int, and long. So if let's say that I'm asking somebody to enter their age, right? We know that people, I mean, we've known people who've lived to 110, but, let's just say they can live up to 150 years of age. So I have to think, well, what kind of data type do I want age? If I create a variable named age, what data type do I want to make it? Whatever data type I make it, that number of bytes is going to be allocated for that variable. So way back, like when I started programming, we actually cared about how many bytes we used in a program. We actually had to be very mindful about that because memory was expensive. Memory is not as expensive these days. Therefore, you don't have to worry about the data type. But I think that if we use the correct data type, it just lets people know that we know what we're doing. So if we're getting somebody's age, we know we don't need we don't need a number this big, do we? A number that's this huge. I can't even, I need to put some commas in there to be able to read it. We don't need a number this big. So why not just use a short? And a short is a number. So short can hold a number between negative 32,768 to positive 32,768. Well, all I need is just 0 to 150. So definitely the short is enough space. So the short only takes 2 bytes of space, which is 16 bits. An integer takes 4 bytes, and a long takes 8 bytes. So also, if you're writing programs for small devices, and maybe it's like a phone that you're writing a program for, then an application, then these are things that you do want to think about, right? Because you don't want your applications to take a ton of memory when they're being ran on the small devices that may not have as much memory. Then we have a byte, and we have char data type. Now, I want to talk about the char data type. And actually, I guess we could use a byte for our number, for our age. Well, it only goes to 127. I mean, nobody lives that. But if we wanted to get to 150, we would need the short. Okay, then the characters are going to be, if you look at your keyboard right now, so looking down at my keyboard, I see an X, I see an F, I see number 5, I see a $sign, a period. All those are characters. Even the space is a character. And so char, what char data type does is it holds one single character. And characters are given an actual numerical value. So in your book, there's a section, I don't think it's on here. Let's see. This is talking about what I just went over. Yeah, it doesn't talk about it. So let me see what page that is where it talks about characters. Boolean is our true, false. So I have the physical book, which I think it follows the same pages as your ebook. It's on page 34. It talks about the different coding schemes for characters. So Java uses something called Unicode coding scheme. And let's see. So the Unicode coding scheme starts at 0 and it goes to 65,535. So those are all the characters that it has. So each number, like 0 is attached to a character, 1 is attached to a character, 2 is attached to a character. So for example, if we look at if you look at capital A is Unicode 65 and capital B is 66. And the reason it does that is because you want to be able to compare characters. So you want to know if A is greater than B. Maybe you're looking at a string and you're looking at people's last names, and the first letter you're going to compare, is A bigger than B? Well, A is 65, B is coded to be a 66. So A is actually smaller than B. And if you know that, then you can sort your data. You can sort your string data. So each character is coded. So character A has a number, character B has a number. Little a has a different number than capital A. And different systems have different codes. And so on that page, it explains like the IBM system has their scheme, coding scheme is called EBCDIC. And there's also the ASCII, which I'm most familiar with. It goes from 0 to 128. And that one, I believe we used that one in C++. But the one used for Java is called Unicode. So let me just show you what that looks like. If you go to your browser and I type Unicode, characters. So here's the list. Go to 60. So the ASCII characters from 0 to 128 at the first 128 characters in Unicode. So let me just show you those. I don't like this table. And a better table. This looks a lot better. Okay. So the number 0 is ASCII value 30. 30 X. It's even in binary. Okay, let's look at capital A. Oh no, it's over here, this number. So this is the number that gives us the ASCII or the Unicode value. So capital A is 65. And so if I'm looking at capital A and I compare it to little a, let's see what little a is. Little a is 97, so capital A is smaller than a lowercase a. It's less than. And it's good to know that because then you can, you know, depending on what you're doing, then you can know how to sort things, or maybe you just want to make everything capital. Also allows you to know, you know, exactly what you're looking at, if you're looking at a capital A or a little a. So that's how characters are compared, how they're stored. And they take up, we go back to the PowerPoint, characters take up 2 bytes of space in memory. So if you think about memory, I just want you to think of, you know, like this piece of paper. So think of this piece of paper. This is, let's say this is how much memory you have in your machine. So if I go in and I decide that I'm going to define something as an integer, and my variable is called sum, so it's going to find the sum of something, then the way that I can visualize that is I'm going to make a box like this this is the memory space. So it allocates, it takes a chunk, takes that box, a chunk of memory. How much does it take? Well, it says here that an integer is 4 bytes. So this chunk is going to be 4 bytes, and it's going to be named sum. And it's going to look like this. So you have this chunk is 4 bytes. Its name is sum. And what can I put in here? Well, I can put a number that is this big, which is, oh, let's see, 1, 2, 3, 1, 2, 3. What is that? 2,147,483,648. If I can put a number that big, negative or positive, in there. So anytime I define a variable, it takes a chunk of my memory. Okay, so we talked about the floating point numbers. Oh, we didn't talk about precision. So floating point data types are going to be able to hold decimal numbers. So let's say if you're finding the average and the average is 95.67, then it can hold that 0.67. What is showing here is we have the different data types of floating point. We have one called float and one called double. Everything in Java is a double, so I would just use the data type double. But double gives you 15, a precision of 15, which means 15 numbers after the decimal. A float gives you a precision of 6 or 7, which is 6 or 7 numbers after the decimal. And so therefore, because this gives you a bigger precision or a better precision, then it's going to it's going to hold more space. I don't think this tells us the size of a float. I have it in the book. Okay, but now you know how many numbers after the decimal. So this becomes important if you're doing some coding that really requires a really precise precision, like in science. And so it would be important to know how far those numbers go. And then Boolean is just true and false. And true is here you see these words that are in bluish purple. These are key words or reserved words. So Boolean's reserved, the word true is reserved, the word false is reserved. True has a value of 1, false has a value of 0, like an actual integer 0, and a true has an actual value of 1, of an integer 1. So it's just some terminology. We can call like the number 23 or the number negative 67. You might hear somebody say, oh, this is an integer literal, or an integer constant, or just an integer. So a literal meaning that 23, we literally mean 23. Constant meaning 23 is just 23 and it's not going to change. It's not ever going to become a 24 or 25. So these are constants. These are not variable names. This is just the number. Same thing for this number, 25.60 is a floating point literal, or some people call it constants. I like to call them constants, or just a floating point number. And then character literals or constants or just plain old characters is just a character. The reason we talk about this is that when you're programming, you either have a constant, like an integer constant, just a number that you physically type into the program, or you can have the user enter a number and it goes into a variable. Well, that number is going to change, right? Depending on the user and what they enter. And so we typically have anything that we have that's a constant, it's a number that doesn't change, we're going to define it as a constant. And we'll look and see how we do that later on. When we look at characters, characters have single quotes, or this is an apostrophe, right? If you look at your computer, this is how you type an apostrophe, but we call them single quotes. So you have single quotes, you only have one character in between and no more than one character. Okay, if you've got 2 characters, it's going to give you an error. It now becomes a string, not a character. Character is just one character. You can also have a space in here, so you can have apostrophe, space, apostrophe. And that is a character. It shows a character. These are arithmetic operators. So we looked at these 4 earlier: addition, subtraction, multiplication, division. We also have one, the percent sign, which is used for modulus. And what modulus does is it gives you the remainder of 2 numbers that you divide. So if you say 7 divided by 2, 7 divided by 2 is 3 with a remainder of 1, right? Because 3 times 2 is 6, remainder of 1. So modulus gives you the remainder, which is very useful at times when you need that. We have what we call unary and binary operators. So unary operators is one of these operators can be used on one number. So addition and subtraction can be used on one number. Like we can say, like I said earlier, we can say positive 25 or negative 25. So these are unary operators. They can also be binary operators because we can say 2 plus 5, which gives us 7, or 5 minus 2, which gives us 3. So binary operator means that you have a number, an operator, a number. Okay? Order of precedence, so this comes from math, it doesn't change. Just like we had in math, multiplication, division, and modulus, we didn't have modulus, but multiplication and division come before addition and subtraction. So this has precedence over addition and subtraction. And we've added modulus in Java. Now, multiplication, division, modulus have the same precedence. It's the same level. So if you have an equation that has multiplication and division in it, then it'll just do whatever comes first from left to right. And we'll look at some examples. That's what it says here. When operators have the same level of precedence, operations are performed from left to right. So if you've got all these three in one equation, it's just going to do them in whatever order it, if this is first, then it'll do that one first. So let's see if we have examples here. Yeah, let's look at these examples. Okay, these are just some, again, this is some vocabulary. Integral expressions, meaning it's just expressions that have integers like 2 plus 3. Floating point or decimal expressions is like saying 2.5 plus 3.7. Mixed expressions, you're adding integers and floating point numbers, like 2 plus 3.5. So let's take a look at this. If you have addition and multiplication, multiplication has a higher precedence. So you would say the compiler would multiply this first. So 3 times 5 is 15. Then it would add 2, and that equals 17. So this equals 17. You don't add the 2 and the 3 first. You've got to multiply first, because these three come before addition and subtraction. Okay, for this one, we have X and Y. So for this one, you've got addition, you have subtraction, and you have division. So division would happen first. Y divided by 7 would happen first. After we got that value, then it would do 3 plus X, and whatever that was minus this. So let's put a value in there. Let's see if we put 14 here. And then trying to make it where it doesn't come out to be negative. Okay, so 14 divided by 7. So this would give me 2. This would give me a 2. Then it would be 3 plus 20 would be 23. 23 minus 2 would be 21. Let's do this again. Let's add some values here. Now, this time we have parentheses. So since there's parentheses here, that's going to take precedence over everything. So we're going to do parentheses first, okay? So let's say we had 10 here for Y. Z was 8. And let's make X 3. So it's going to do parentheses first. So this would be 2, right? 10 minus 8 is 2. Then we would start from the left and go to the right. We would do multiplication, division, and modulus first. So I see multiplication here. So I'm going to multiply 2 times 2 is 4. Start from the left again. I don't have any multiplication or division or modulus, so I'm just going to do my addition. 3 plus 4, 4, 5, 6, 7, that's 7. And then 7 plus 18 is 25, right? So that's how we do order of operation, just like you've always done in a math class, except you've got division. Looks a little, your signs look a little bit different. This one looks a little bit different. But still follow the same procedures. Okay, so let me erase everything. Clear. All operands are floating point numbers. Okay, so in this example, it's just showing you how we're just adding all floating point numbers. And again, in this example, let's say that so here we would multiply first. Trying to get my pen back. Okay, well, we would multiply first and then subtract. Here we would multiply first, then add, and then subtract. Mixed expression, this is an example of mixed expressions. So we've got an integer and decimal, 2 integers and decimal. It says integer operands yield an integer result. So what does that mean? Get back my pen. Okay. So in this example, where we have 6 divided by 4. So if you were to divide 6 by 4, it's going to give you a floating point number, right? So it's going to be 1. 4 goes into 6 one time with a remainder of 2, and it would be, so if I get my calculator and I do 6 divided by 4, it would equal 1.5. So because both of these are integers, I'm not going to get a 1.5. I'm just going to get a 1, because when you tell it to divide 2 integers, Java says, okay, you want me to divide 2 integers? I'm just going to give you back an integer. Now, so this divided by that, this is going to be a 1. And then 1, keep wanting, if it lets me annotate. This would be a 1, there we go. Then 1 plus 3.9, that's going to equal 4.9. Now, it does 4.9 because you've got one floating point number. If you have one floating point number, then it's going to give you a floating point number. So this would be 5.5. Now, if I were to say, so let's erase this, clear this. If I were to make this 0.0 like that, then it would give me a 1.5. So if I make one of these floating points, then I'll get back a floating point number. So then it would give me 1.5 plus 3.9. So we also have an option to convert data. So for example, here, I can take this 7.9, add it to 6.7, and this is going to give me 14.6. But because I put int in front of it in parentheses, I'm telling it to take that, that 14.6 and convert it to an integer. So it truncates it, it just drops. So this here is going to drop the decimal. Same thing here, it drops the decimal. So you got 7 integer. So it says make 7.9 an integer. So it just makes this a 7 and we add it to the 6 and we get 13. So here, this, let's see if I can add it to it. Okay, so all this gets added, so we have 14.6. That's what the sum is of these two numbers. Then we tell the compiler make this an integer. So it just gets rid of that 0.6. Here, we get rid of that, we get rid of that, and then we add it and we get 13. All right, let's take a look at the next slide. Okay, so the next slide, we're starting on strings, so we'll do a different video for strings. I did want to go back just for a second. I do want you to run on the compiler. I want you to just open it. I want you to run this program and then kind of play with it. So if I run this program, it outputs the words hello world, which is these words here in green. So what I want you to do is play with this, like take the green out, right? And put something else like the number 100 and then see what happens when you run it. Just print the 100. What if inside the quotes we do 100 plus 200? Does it print 300? It doesn't print 300, it just prints 100 plus 200. Just prints whatever's in quotes is just the string. If you want to actually add and see 100 plus 200, then you've got to take the quotes off. And then we run it. And now it prints the 300 because it actually is adding those two numbers. And remember, these two numbers are called integer constants or integer literals. These are constants. So play with the print line, play with the console and just try out some of these things. You can also try out some of the things with divisions. So for example, if I divide 100 divided by 33, because it's two integers, it's just going to truncate. It's not going to give you a decimal number. But if I divide it by 33.0, then it gives me the floating point number. Okay, because I'm telling it I want a floating point number. So play with that. You can also maybe just play around with the order of operation. Type in some numbers, see if you can figure out what the order of operation is going to be. There's also some exercises in the back that you can practice with order of operation. You can always type this into the computer and see what the answer is. But in your quiz and your test, it's going to have some questions to test to see if you know order of operation. And they're going to look like this. It's going to look like that. So that is at the end of the book under quick review. No, let's see if it's quick review. Under exercises. I believe it starts on page 97, page 98. It has some expressions that you can try out and see if you can get the right answer. Okay, just email me if you have any questions. You have my email. I was trying to see if the answers are somewhere on here. They're not. Okay. And I'll see you at the next video. Thank you.